Hi class, in the last lesson we looked at permutations where we were dealing with an arrangement of objects in a particular order. In this lesson we'll be looking at the concept of combinations. Now a combination by definition is a grouping of outcomes where order does not matter. So let's consider a practical example down below. A team of 8 basketball players needs to pick a captain and a co-captain. How many possible combinations are there? Well, let's consider some of the information that we have. So we got 8 players that need to fill 2 positions, a captain and a co-captain. So we've got players 1 through player 8 just as a visual right here. So one way we can visualize combinations is by, of course, making a list and listing out all the possible combinations. Now, as you can tell, this can be a very long and drawn out process depending on how many different groupings that we're considering. So if we look at player 1, here are all the possible ways that he can pair up with player 2 through 8. And then when we go to player 2, here are his ways that he can pair up. And again, remember, order does not matter. And then, of course, it's like a sliding scale down the list. And if you're to count up all of these pairs or combinations, we have a total of 28 combinations. So that is one way that you could calculate combinations, is by listing out all of your possible arrangements. But as you can tell, it can be a very tedious and very long and drawn out process. Another way that we could approach these types of problems is by using a formula. So the formula that we're going to use for combinations is very similar to the formula that we use for permutations. It's this abbreviation NCR, where N refers to the number of objects, and then R represents the number of arrangements or positions that we're dealing with. So the way that we calculate combinations is by using this formula, where we would do 1 over r factorial times the permutation of n and r. So if you forgot how to calculate permutation, make sure you go back to the previous lesson material and review over how to do that. Now let's put that formula into practice. We'll use the same values like we did before in the last example, where we had 8 players and 2 positions that they need to fill. So we're going to look at the combination of 8 and 2, so 8c2 equals, and then here's how our work would be set up: 1 over 2 factorial times 8p2. So now if we were to show our work for this problem, 1 over 2 factorial is the same as 1 over 2 times 1. And then 8p2 is the same thing as 8 times 7, because remember, we're dealing with the first number 8 right here, and then just the first 2 arrangements, so 8 times 7. And of course, if we were to calculate that down, 1/2 times 56, or 56 over 2, which gives us a total of 28. So that matches what we had when we looked at our first method of making a list. So you do have 2 different approaches on how you can calculate combinations. You can either list out all the possible scenarios, or you can use the combination formula. It does take a little bit of practice to do. Now, thankfully, of course, if you've got a calculator such as the Multiview here, or any type of scientific calculator that has probability functions built into it, then you can use the combination command that's built in. So in this calculator, if you hit the PRB button, the second choice is NCR. So that is the command you would use for calculating combinations. So on this calculator, the way how you would calculate this problem out, 8c2, you would just type it in as so. So we would hit the 8, then the probability button, NCR, and then choose 2. So that's what the format looks like. Hit enter, and there's our answer, 28. I hope I didn't go too fast through the lesson. Please let me know if you have any questions for me, and I'll be glad to help you out. Let me know in the comments or private message me if you have any issues.